Hey everyone, welcome back to our channel Code with Vishesh. So for today, our problem is the celebrity problem. So what problem states, we will let it know. Uh, Before that, I am telling that we are ahead to cover our Stack Q playlist, and we are in the end of our list playlist. Tomorrow will be the last video that will be coming for the Stack and Q playlist, and after that we will be practicing upon some questions of stack and queue over lead code. So for some days I will be practicing again and again on stack and queue. So coming back to our question, the celebrity problem. So what problem says, we have given a matrix of n cross n matrix, and their elements are filled with 0 and 1s. There are two value only, 0 and 1. So 0 defines that the person does not know anyone, while 1 defines that the person knows anyone. So how we will check if a person knows anyone and if a person don't knows anyone, and who is the celebrity? So for definition of celebrity, the definition of celebrity is that the person everyone knows him, means the celebrity will be known by every person, while this celebrity does not know anyone, so he knows no one. So this is the problem, and the celebrity who does not know anyone but everyone knows the celebrity. So how we will check if a person is a celebrity or not? Let's come. If there is a matrix of 0 comma 2, means 0 row and 2 column, and it is 1, that shows that 0 knows 2, as this box contain 1, and this index contains 1. So here our 0th row, matlab 0 knows 2, that's why it is 1. While if it is 2 comma 0, and suppose there is a 0, and so what does it states? It states that 2 does not know 0. So this is the problem statement and the flow. And so in this case, there is also a case like in diagonal, no one knows no one, means me myself know very well, but here I will consider it as 0. So our diagonal will be always 0, and there will be always n cross n matrix, and we have to return the celebrity. We have to find the celebrity, whoever is the person who does not know anyone while everyone knows him. So we have to return that index in our question. So this is the problem statement. Coming upon the brute force, what I have analyzed. So in our 2D matrix, we have given some element as 0 and 1. The 0 defines the person does not know anyone, while 1 defines the person knows anyone. Means row number will be defined as 0 comma 1, means 0 knows or does not knows 1. So how we will solve this problem? So what triggers in our mind is, we can take two different element, where two different arrays, where our first array will be the elements with contain know me, and the second one will be does not know me or I know them, means two different array. First array will be the person who knows me is the first array, while the second array is to whom I know, means we will be checking for every row and every element or every index where we know them or either they know us. In two different array we will be marking them, and in the end, after the traversal, we got there a case where everyone knows me, marks the maximum number, while I don't know anyone, so thus it will be showing 0. So the index whichever the which have in both the array have same different value like maximum and 0, so we have to return that index itself. So this is the problem flow of brute force. So coming upon the pseudocode, before checking the pseudocode, let's analyze like maximum number of people to who can know is n minus 1, while the minimum person or means let's suppose a 4 cross 4 matrix, and here I think three persons are the maximum person that know me, because I know myself. So there will always be the zero, and all there are three different person or three different rows or column will be available. They can know me or either I can know them. So n minus 1 will be the maximum number, and 0 will be the number where no one can know me or I can know everyone. So we will be traversing from our first index till last index and marking all the values. If I know anyone, I will be marking in a I know array, and if the person knows anyone or me, though we will be marking in their index. So that's how this problem will be solved. Coming up on the pseudocode now. So we will be taking a function that contains a matrix, and we will be taking two different array. First array is know me, while the second array is I know. Okay. So they will be of n size array, and n can be calculated by matrix dot size. And now we will be traversing from our I will be traversing from 0 till n minus 1, and our j will be traversing from 0 till n minus 1. And in this condition we will be checking, like, if matrix of ij is equal to 1, means I knows j. So know me of j will be plus plus, and I know of I plus plus, means they will be incremented by 1. Like, I know anyone and anyone know me. So if a matrix of ij is equals to 1, that shows that I knows j. So our know me matrix will be incremented by 1, and I know matrix will also incremented by 1. And after this we will be traversing we will be ending of our matrix loop, and after that we will be again traversing from 0 to n minus 1, and we will check if our nomi of I is equals to n minus 1, means maximum number of people that knows me is n minus 1. So what we have to return is celebrity. So everyone should know the celebrity. So know me of I is equals to n minus 1, and I know of I should be equals to 0. Yes. So if I know of I is equals to 0, and know me of I is equals to n, just we have to return that I index. So we will be returning that I index. And if it is not the case, then there is a case that there is no any person that is a celebrity. So we will simply return minus 1. So this is the brute force. So for the brute force, time complexity will be reached to big O of n square for the marking of elements, and big O of n for the traversal. So big O of n square plus n, that is the time complexity. While space complexity, we have big O of 2n, because we have taken two different array of n size. So space complexity. So here we are taking extra space, and time complexity is also in n square. So it is not the optimal solution. So we have to optimize it. So what will be the optimal solution? Before getting to the optimal solution, let's analyze some conditions, like minimum celebrity. So in our matrix there will be a two case. What can be a number of minimum celebrity, or what can be a number of maximum celebrity? Means we can have zero minimum celebrity. There can be a case where in our matrix there is always a 1, means everyone knows everyone. So there will be a case of this, and in this case no one is the celebrity, because everyone knows everyone. There is not any person who does not know anyone. So that's why there should be also a case if all have one. And what can be the maximum number of celebrity? Let's analyze. uh, the definition of celebrity was that known by all, but he does not know anyone. So the maximum celebrity is one only, because if let's take an example where x and y are two different celebrities. So it cannot be possible, because there is the condition that the person should not know anyone, and and everyone should know him. So there that cannot be possible for x and y both, because everyone will know x and everyone will know y, And if it is the case, then X should know Y or Y should know X. Anyone should know, anyone should know the one person. So in this case, maximum celebrity will always be one. We have to remember this and this condition. So let's come upon our approach what we will be using. So we will be taking two different pointer, a top pointer and a bottom pointer. We will be marking it in our row indexes, our first row index and our last row's first column index. So we will be marking top and down, two different pointer, and we will be checking up to top and down crosses each other or top goes greater than our down point. So how we will be traversing? Let's suppose there is a row of our top pointer is at our first row and our last, we are taking 4 cross 4 matrix, and our top pointer is at our first row while our last pointer is or our down pointer is at our last row. So there can be a case of, let's suppose we should check for 0 comma 3, just taking a random number. So in this case 0 should know 3, and if it is the case, let's check if 0 comma 3 mein 0 knows 3 or not. If 0 knows 3 means there should be a 0. If 0 knows 3 means there should be a 1 in 0 comma 3. And if 3 knows 0 means 3 knows 0, 0 knows 3, 0 comma 2, 0 comma 2 equals to 1, comma 0 equals to 1. Okay, so if 0 comma 3 is the index, let's check, and if there it contains 1, that shows that 0 knows 3. If it is 0, that means 0 does not know 3. So let's take an example where 0 does not 3. In this case 0 can be a celebrity, so we will not move our top pointer. Now we will check for the down pointer at same index. So does 3 comma 0 knows anyone or not? So we will be checking at that index, is it is 0 or 1. If it is 0, that means 3 comma 0, 3 does not know 0. So 3 can also be a celebrity if it is 0. And if 3 comma 0 contains 1 in their index value, so that shows that 3 knows 1. So 3 can never be a celebrity because he knows someone. So in this case our 0 can be a celebrity and 3 cannot be a celebrity. So our down pointer, every element means 3 comma 0, 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4. So they can never be the celebrity, 3 can never be the celebrity. In this case we will be moving our down pointer to one upper level and incrementing our down pointer, decreasing our down pointer. We will do down minus minus, and eventually our down pointer will move to the second row, and it will be checking for the 2th row, means it will be 3 because 0 to n minus 1 we have elements. So we will be checking for 2 now, and now again checking for those element. Now we will be checking, does 0 comma 2 knows anyone or not. Means first we will be checking for 0 comma x element. 0 comma means our top row element, top rows index, we will be taking that index, and our down index, down rows column index we will be checking firstly, and if it is the case then we will be checking for its transpose column also. So for in this case 0 comma 2, let's check. So if it is the case like 0 comma 2 contains 1, if it contains 1, that means 0 knows 2 and it can never be a celebrity. And in this case we will be moving our top plus plus, and our zeroth we will be moving from 0th row to first row. So let's take example where we move to the first row, and now we will be checking for, does 1 comma 2 is equals to 0 or 1. If it is 0, that means 1 can be a celebrity because 1 does not know 2, so maybe he can be the celebrity. And if 2 comma 1 is 0 or 1, we will check. If it is not, if it is 1, that means 2 can never be a celebrity, and we will eventually increment it by or decrement it because it's a down pointer. So we will decrease our down pointer and it will goes to 1. Now the case comes where 1 comma 1 arises. So 1 comma 1 is always 0, and that's how we will move and get up to the markable row where we want. And for the confirmation we can also check another thing, like in this row every element should be 0 because that is the celebrity row. So 1 comma 0, 1 comma 2, 1 comma 3, 1 comma 4, everything should be 0 because one does not know anyone. So in this case every our row should be in a 0, while in our column our diagonal matrix element should be 0 and every other element should be 1 because every other element knows our element 1, or every other element knows our index that he is the celebrity. So we will be checking them also in our condition, and that confirms that this is the final index. So coming up on the pseudocode, so for this we will be taking a function matrix, and in this we will be marking our top as 0 while the bottom is n minus 1, that's the last index. Or now our top and down are both initialized, and n can be initialized by matrix dot sides again. And now we will be checking our while loop does if top is less than down. Until that we will be moving, means top crosses the down pointer. Until that we will be moving and checking if our matrix top matrix of top and down, means if that element is equals to 1, in this case top should be incremented because top is not the celebrity anymore. And if it is not the case, then else if there also may be a case that our matrix of down and top should be equal to 1. In this case our down pointer knows the top pointer, then it cannot be a celebrity, so down minus minus. And if it is not the case, uh, there may be a case where they both don't know or don't know each other, mean they can both can be a celebrity or both in there may also a case where they both know each other, and in that case both will be incremented or decremented. So top will be incremented top plus plus and down will be decremented by down minus minus. And after that we will be checking if our top crosses down. Now that case will be arise where we have to check our row, either it should be all 0 and our diagonal or column should be always 1 except diagonal box. So for we will be transversing again from 0 to n minus 1 where we will be checking, and there may also a case where top is greater than down and we does not find any celebrity. So for that case we will be returning minus 1, and our top is equals to our down because they both are on the same level now. And we have to ignore the diagonal box. So if it is the case, so we will be continuing if I is equals to top or down. So we will be just continue because we have to remove that box and we have to check for the entire column and entire row except that diagonal box. So for the row we will be checking condition if matrix of top of I, means our top is on the row. So we are checking for the row if they are equals to 0, and with this our matrix I comma top should be equals to 1, means every other element should know the celebrity or the element. So in this case we will be returning our element, else we will be returning minus 1. If it is not the minus 1, we can remove we can return either top or either down because they are both on the same point and top is equals to down already. So that's how we were able to solve this problem. And coming up on the time complexity, we are taking time complexity of big O of 2n because we will be traversing again and again big O of n for our first traversal and checking the condition, and big O of n for the next traversal where we are checking for zeros and ones, either they are in completely row or not. And for the space complexity we are taking big O of n, that's the space that is given for our matrix itself. We are not taking any extra space other than this. So that's how we will able to optimize the solution, and our question ends here. So hope I was able to understand you the problem and their brute force and workflow. And with this, we will be moving ahead to our next question. And our next question will be the implement LRU cache that we will be discussing in our next and last Stack and Queue playlist video. So until that, stay tuned, stay happy. We will meet in our next video.